Buongiorno everybody and welcome. Thank you for taking the time to join me for this virtual session about OAuth 2.1 and APIs. My name is Vittorio Bertocci and I work for OAuth2.1. My agenda is also my too long didn't read for the entire session. OAuth2 has been extraordinarily successful in providing guidelines and practices for protecting APIs in the last decade. OAuth2, however, leaves you a lot of leeway and freedom, leaves large parts unspecified. And the outcome is that people didn't always made the best choices for filling those blanks. And so the standard authors kept working on producing extensions that would give more specific guidance for those areas that were left as exercise to the reader. The outcome is that today, if you want to know what's the latest and greatest, you have a very large sprawl of documents you have to go after. And it's very difficult for the non-initiated, someone who's not working in this space, to truly understand what are the relevant documents, the relevant parts of the documents. That's where OAuth 2.1 come into play. OAuth 2.1 is a revision of the core specification of OAuth 2, which brings in the core specification some of the key advancements which have been made in the extensions and eliminates some of the things that have been discovered to be not particularly secure. So I'm going to explore these three areas, and hopefully by the end of the presentation you'll have a good feeling of what OAuth 2.1 is about and how it works for you. Now, this is important. You normally don't need to read the specifications unless you work in identity, you own an SDK and similar. In order to use OAuth, you don't need to read everything. But I hope that the session is going to be interesting anyway, because you might see some of the requirements surface, even if you don't work directly at the protocol level. All right, OAuth 2 and APIs. Let's take a little refresher. Like most people think they know what OAuth 2 is, but in fact, what they're thinking of is token-based authentication. And they think that everything that is part of that is part of OAuth. And in fact, OAuth is a pretty narrow thing. It focuses on a specific subset of all the things you can do in identity, but in particular in authorization. It was introduced in 2012, and the main thing it does, it teaches to applications to be clients of third-party APIs. So a classic scenario, you have LinkedIn that wants to call the Gmail APIs for sending mails to your contacts, for sending invitations. That is the quintessential OAuth 2 scenario, in which you as a user give a delegation to LinkedIn to call Gmail APIs on your behalf. In practice, once we had this mechanism for obtaining tokens and using them to call APIs, this mechanism has been stretched to cover way more scenarios in way more contexts than web apps. So we'll touch on some of them. Now, let's actually take a concrete look at how this worked. Again, many of you will already know, but I just want to be sure that we are on the same page before we start building on top of it. What OAuth did was to introduce this new entity called the authorization server, and this entity is what takes care of interacting with the user for giving to the user a chance to grant consent for an application to call APIs on the user's behalf and provide all the mechanics for doing that. So let's just take an ultra quick look of how this works. The first thing is that when a web application wants to call an API on behalf of a user, it will craft a message in OAuth 2 syntax, and it will redirect the user from the website to one particular endpoint of authorization server, which is called the authorization endpoint. Here there will be some authentication taking place, and then the authorization server will tell the user, dear user, application web app wants to call APIs on your behalf with those permissions. Are you okay with that? And when the user says that yes, it's okay, what happens is that the authorization server notes down those options, those grants that the user gave, and then sends back an artifact called the authorization code to the browser. Next step is the browser sends back this authorization code to the requesting application, and then the requesting application turns around and uses this code together with its own credentials and similar. I'm not going into the details because we don't have a lot of time. It redeems this code and gets back what we call an access token. An access token is an artifact designed to grant to the web application client access to the API within the boundaries of what the user allowed. So in the example that we said earlier, say that LinkedIn now can send emails on behalf of the user, but cannot, for example, read the emails. And when the API call occurs, the client attaches this access token, which we will often hear defined as bearer token, to the request. And upon receiving this token, the API will decide whether the user can do the action, the client can do the action that it is requesting. Nice mechanism, very powerful. And this scenario with the web app just happens to be the most common, the paradigmatic scenario for which Auth was created in the first place. But if you read the specification, you'll see that there are multiple what Auth calls grants, which are different ways in which clients can go to the authorization server and obtain access tokens for calling APIs. Those different grants reflect the different types of applications of clients of devices that could request the token. And each of those clients and API and clients, application types, and similar have different security characteristics. And that's why we have different grants, because those grants leverage their capabilities and try to minimize, contain their security shortcomings. So that's the absolute basic of Auth. Now, as I mentioned, Auth2 is underspecified. Let me be a bit more concrete about this. For example, think about the case in which you are an API developer and you want to use Auth for protecting the calls to your APIs. You know from the spec that you should expect an access token, and you should use the access token to decide whether the caller has title to make the operation that they are requesting. But Auth doesn't tell you at all how to do that, how to decide whether the token is valid or not. People substantially struggled to find a way to decide whether a token was valid, and multiple approaches have been devised. For example, OpenID Connect defines a format for its own tokens. Their tokens have a different purpose, but people saw that they use the format, they use the mechanism for deciding how to validate this token, what keys to use for verifying it, and so they just borrowed this system and applied it to APIs as well. But Auth doesn't tell you that a token has to be in JWT format. It doesn't give you a format at all. So some people use the JWT in their own way. Some other people introduced an extension to Auth which recreated this idea of shared memory. The idea is that when you receive a token as an API, you can turn around and hit again the authorization server through a special endpoint called the introspection endpoint, which is a server-to-server tunnel, hence authenticated. You know the identity of the server, and you simply turn around, send the access token, and ask the authorization server, is this yours? Is it valid? What's inside? What should I do with it? So this is an extension to Auth. Today, we are working on an extension which actually tells you how to use the JWT format for access tokens in the right way. But the main point here is this was a giant area which was left as exercise to the reader in Auth, and it is an area which is covered by multiple extensions from Auth and multiple concrete practices. Let me make another example. Think about specific types of applications. Auth2 describes the fact that you can use it for native clients, you can use it for user agent apps, so single page apps and similar, but doesn't really go into any details about how to do that. So for example, when you're in practice, you try to build a native app, at a certain point you need to pop out a browser surface because Auth requires you to hit the authorization endpoint for consent, for authentication and similar. The way in which you do it is not described in Auth. And at first, people had this practice of embedding browser controls in their apps, but these had lots of shortcomings, like the app could capture keystrokes. The app could not reuse existing cookies, so even if you were signed in the browser on the device, in the identity provider you wanted to talk with, you had to sign in again because your browser control didn't have access to the same cookies. So, long story short, there was a missing guidance there. And so the outcome was that the standard working group put together documents which describe how to do native clients, describes how to do browser applications, so how to deal with the token dance when you are doing things on JavaScript. And for the particular scenario of a native client that I described, the main solution was to outsource from the app all the interactions to the system browser. Let's say that when you write a mobile client and you want to authenticate the user, all you are required to do is to actually invoke the system browser on the device and have a system browser perform the interactions with the authorization server, which solves the problems I mentioned there. Now the app cannot use keylogging for capturing credentials. And now, given that it's the system browser, you can reuse existing cookies and do single sign-on. However, this introduced a security problem, which was now the system browser had to communicate back the authorization code to the app once it was done, and that created the opportunity for other applications on the device to intercept the code. So the working group once again created one extension, which is called Pixie, which is a mechanism for protecting the authorization code exactly in this scenario. So another very important extension which you need to be aware of because it's used everywhere, but if you just read OAuth2, you won't see it. Finally, just for rounding this up, security is always a top concern in here, and the fact that Auth uses bearer tokens means that those tokens are vulnerable to that guy, which is basically anyone who could inject itself between the caller and the API. And if a token, a bearer token, is intercepted, then the person that intercepted it can now use it and impersonate whomever the client was, with no way for the API to tell whether that's the case or not, which is a huge intrinsic problem in the system, which is like in Auth2 is entirely predicated on the assumption that you can do everything on a secure channel. But there are many ways in which this assumption might not be true, or sometimes the client might be tricked into sending tokens to a different destination, which now can turn around and use them. So long story short, lots of security problems. And once again, the working group produced guidance, trying to identify the most common mistakes and highlighting things to do, things not to do. Highlighted the scenarios that are more at risk than others, and introduced new capabilities such as MTLS and in general ways of binding the tokens to a channel or to a particular client so that scenarios in which an intermediary steals the token are not as painful. So once again, one large category of revocations. In the context of security, here is an important point. Some of the things that are described and sanctioned in Auth2 are actually not particularly secure. Now, I don't want you to panic. That doesn't mean that those are like zero-day vulnerabilities and similar. Those are just things that are tricky to protect. And so we have observed through the years that when people try to use those particular flows, those particular grants and aspects, they are more prone to errors than if they use some other alternatives. So now you have also the problem that when you read Auth2, you need to be able to spot those problematic areas and not follow that particular guidance. And you find out when you read the security BCP, but in fact, if you don't find the right security BCP, then you might miss this, and you might actually end up using guidance, which again, it's not something that is like a zero-day attack, but it's something that can give you problems. You need to think about how to secure it more than necessary. If you'd use something else, you'd be better off. And now, just for giving you a sense of how vast the sprawl of extensions is, here I'm listing some other random extensions which are important and augment Auth2, and that, of course, are not part of the core. So navigating all of these is really hard because you need to be aware of existence of those extensions. Of all of those, you need to understand which ones make sense for your particular scenario. Some of those extensions are fundamental, like Pixie, but others are a bit more exotic, like the extensions which tell you how to get a token when your device doesn't have any chance of popping out a browser. It might not be relevant to you, but it's still there. So if instead you happen to have that scenario, you need to find it, you need to read it, you need to incorporate it in your thinking. Now enter Auth2.1. Auth2.1 is a consolidation of Auth2 core and better usage, which is another ancillary spec which detailed how to use tokens for calling APIs. And it consolidates Auth2 core, better usage, and some particularly important extensions. These will save you, if you are one of the people that need to understand specifications, it will save you the need to track down and digest all of these other extensions. And in so doing, it also removes some of the things that proved to be particularly problematic. Now, super important, at the time of this presentation, Auth2.1 is still a document being discussed, actively developed in the working group. So if you listen to this presentation months from now, just know that some of the things that you have in here might not be 100% accurate. That's my theory, and I'm sticking to it. Now, more in details. We said this. Auth2.1 is Auth2 core, it's better usage, plus a Pixie specification, this mechanism for protecting authorization code. The recommendations in the security best current practice document, the recommendations from the native apps and browser-based apps best current practice documents as well, minus some of the things that have been identified as insecure. Now let's go a bit more into the details. Now what you see in here is a collection of some features that are defined in Auth2. Auth2.1 overlaps with Auth2, and the drawing here is somewhat misleading because the overlap is almost complete. So Auth2.1 selects out some things, like keeps some things, most things of Auth2, excludes those elements, which we'll revisit in details in a second, and introduces some new constraints. One specific goal of Auth2.1 is not to introduce anything new, no new constructs. It only adds refinements and extensions which already exist in the wild today. It just brings them back into the core, but it doesn't really introduce things that don't exist in the wild. So let's see in details what's happening there. One thing that is being removed, which is relevant for API developers, is you are no longer allowed to send access tokens in the query string. This was something that the bearer token specification allowed. It was always horrible practice. Luckily, nearly no one is doing this, but now explicitly we removed it. Then, the resource owner password grant is now gone. Auth2 had provisions for a resource owner, a user, to send username and password raw directly to the token endpoint of the authorization server instead of going through the experience of the authorization endpoint. This is incredibly problematic, has lots and lots of issues, and it goes in general against the spirit of OAuth, as in enabling third-party apps. So now it's OAuth2.1 doesn't include anything about that grant, hence that grant is no longer part of OAuth2.1. Similar considerations go for the implicit grant. OAuth2 includes a grant called implicit, which in a nutshell means you get a token, an access token, directly from the authorization endpoint. This was a trick used for enabling user agent applications that run JavaScript that calls APIs, hence need to obtain an access token directly in JavaScript. However, technology advanced, and in particular CORS, a mechanism for making programmatic calls cross-domain from the browser, is now ubiquitous. And so now you can actually use the same flow that you do in terms of authorization code, which normally would do part of it on the server side. Now you can do the entirety of this flow within the browser. And so there is no longer the need to use the implicit grant as a workaround, and so the implicit grant has been eliminated. There is a longer discussion to be had about some derivatives of these. For example, OpenID Connect uses a form of implicit grant for obtaining ID tokens, which are different from authorization tokens, different semantic, and above all, it obtains those tokens by using the form post, as opposed to placing them in the query string. So a lot of the security problems don't apply. So the fact that OAuth2.1 removed the implicit grant doesn't mean that using the implicit flow in OpenID Connect for ID tokens, not for access tokens, is insecure. OpenID Connect use of implicit for ID token is still valid. Now, what did we add in OAuth2.1? We added the requirement to use PXE everywhere. PXE was introduced for the scenario that I described earlier, native clients using the system browser. However, it turns out that there are other attacks that can actually apply. The other thing that was introduced is that refresh tokens now need to have a higher level of protection. Refresh tokens are entities which clients can use for getting new access tokens without starting interactive prompts with users again. And so the outcome of this is that if you are a native client, and when you are a native client, you don't have secrets associated to your client, so you cannot prove your identity when you are using refresh tokens with authorization server, then you are in a very flimsy position, because if now any attacker intercepts the refresh token, now they can not just use that token like that was the case for access tokens, but they can mint new tokens. So the remediation, such as having short-lived tokens, which normally helps to mitigate issues with access tokens, don't apply to refresh tokens. So OAuth2.1 goes a bit farther than OAuth2 and says, dear client, when you get a refresh token, you should use some extra protections. So if you are a confidential client and you have credentials, you are fine. If you are a native client, a public client, then you should either use some mechanism for binding your refresh token to yourself or to the channel that you're using, or you should use rotation. What is rotation? The idea behind rotation is that whenever you use a refresh token, that particular instance of a refresh token stops working. And you need to have received a new refresh token, and the next time you want a new access token, you need to use the new refresh token. If you use the old one, the authorization server will infer that someone stole it and is now trying to get tokens on your behalf, and so now it can take remediation such as revoking all the tokens issued up to that point. So OAuth2.1 recommends this extra protection for refresh tokens. Then all the flows which deliver artifacts back to your app, like tokens and similar, rely on the fact that when you register your client, you specify a URI where you want to get tokens to. It's super important because, as we said, if someone can get their hands on a token, then they can impersonate you. So it's super important that an application registers only the URIs at which it is willing to receive tokens, and it's important that the authorization server uses those URIs with an exact match, as opposed to allowing attaching further parameters or further segments of a path to them. One of the big security issues that was discovered in the context of Auth2.1 was exactly that some authorization servers were lenient and allowed partial matches for those URIs. The outcome was that there were a wave of redirect attacks in which, by cleverly attaching to the path some extra parameters, attackers managed to hijack redirects and obtain tokens which weren't meant for them. So in Auth2.1, we introduce an extra requirement that authorization servers must do strict URI match. Finally, in the wild today, there is a client type which is somewhat between public client and confidential client. So it's a client which starts its life as a public client, so no credentials, but it uses some mechanism for dynamic registration to get the credentials which are assigned to the client that can be used to the authorization server to prove that the client is actually the same client as the transaction that occurred just a few moments ago. It's not a confidential client because a confidential client has credentials that are agreed upon at the registration time, and so those credentials can be used to prove the identity of the client. Now let me summarize what we got here. If you are a developer of APIs, basically nothing changed for you. Nearly no one used query strings, and you shouldn't have used it to begin with. Mostly everyone expects tokens in the authorization header, so nothing changes on your side. If instead you work on the client or on the authorization server, what happens is that Auth2.1 gives better security guarantees because it has stricter requirements. And if you are using the flows that I mentioned are now no longer being included in the spec, now you are no longer compliant. So if you're using resource owner password grant, if you're using implicit grant, then you are not Auth2.1 compliant. That doesn't mean that you have to drop everything, but it's something to be kept into account. So for all new work, it's probably a good idea not to use them. Again, let me restate, if you're not an identity specialist, you don't really need to work at this level of detail. However, you will see some effects of those things. So if you have an SDK that supports Auth2 and uses the services that does Auth2, maybe you are able to use this substring match when you do redirect URIs. Or maybe you get away with using refresh tokens in a native client without any further check. Instead, if you use an SDK that supports 2.1 for a service that implements 2.1, then now you need to actually use a precise match for URIs, and you might see some network errors that before you didn't see when the refresh token fails to do the rotation. And so as a developer, even if you're not an expert, you might see some of those differences, but ultimately you should find comfort in knowing that it will be significantly more secure than with 2.0. Well, that's it. I hope it was useful. If you have questions, you can find me on Twitter at that handle. And I plan to participate to the live Q&A when they will broadcast this session at the conference. All right. Thank you so much. And see you around.